Hello and welcome to the video lecture review on the JBL book for wireless and mobile device security. This is the second edition. This is written by Doherty. ISBN number 9781284211726. First of all of the material is copyrighted through JB Learning. They own the rights to all of this. I am just providing video lectures for my classes. I do not represent them. PowerPoints are owned by them solely. All of this is copyrighted through, again, Jones and Bartlett Learning. So for any of that information, reach out to them. This is just a lecture review on their official PowerPoints. Alright, with that said, let's jump right on in. Alrighty, Chapter 3, Anywhere, Anytime, on Anything. There's an app for that. So again, we're going to be focusing on the wireless components, and we're going to get into things such as IoT. We're going to be talking about mobile and cloud-based computing, wireless tech. We're going to get into application and basic security controls. The main focus is going to be that zero trust concept. So basically this module is about being able to describe technologies and the architecture that supports wireless communication, things also including Internet of Things, IoT, and we're going to keep it very general, just IoT, none of the specialty or subcategories. And then we're going to wrap it up with our cloud environments. So again, we're kind of wide breadth, but we're not going to be going too deep, so let's go ahead and let's jump right on in. So first things first, let's talk about mobile applications. So mobile apps are designed to do, a task. Easy and just simple. Whether it is a social media app, whether it's a browser, it does whatever its task is. That's it. If you look at Twitter or X, whatever you'd like to call it, it launches its application. If you want to open up Calculator, again, on your mobile device, that's what it does. Some might be able to argue that if you're looking at your web browser, the web browser itself is just that. It is one of the key applications, but it does that application just that well. There are vendor-specific apps. There are apps basically in all of the major app stores. If you have an Apple phone with iTunes, or if you have a Google-based phone with the Play Store, again, every variation. These vendor app stores essentially make it a little bit safer to download apps. However, some app stores are safer than others. Apple, for example, does require code checking and an application fee and all of these other checks and balances, where other app stores, they have their own controls, all with the purpose of being able to share applications with confidence. Oftentimes, mobile app development will include easy access to software. Oftentimes, those software is going to be a software development kit, or SDK. Basically, it's low development cost, ease of publishing, and ease of use for the general individual. This allows pretty much anyone to be able to jump in with some little coding experience and actually develop additional content. So there are options there when we're talking about our applications. Well, it gets really interesting when we're talking about application protection on a mobile device. The big thing is trustworthiness of that app store. Now, granted, both iTunes and the Google Play Store have things slip through. Rare, but it does happen. So again, that user training component also has to be there. You can't solely rely on, the App Store should be able to protect it. That's not how this works. So convenience, oftentimes in mobile technology, trumps security. It's just, we're dealing with end users. They don't want to be inconvenienced by having to unlock their cell phone. That's been a huge thing. Or again, having a basic PIN number, so if you happen to lose your cell phone, someone can't get into it, with normally 000, 111, 123, 4, 5, 6 being the common PIN codes for mobile devices. There's a lot of functionality, and there's very little security and privacy awareness in our average user. So this becomes a huge security problem. So developers could request access to functions regardless of the relevance to that application. People don't realize that your cell phone, when it connects to a cellular tower, it will listen to whatever the cellular tower asks for. If by chance you're actually connected to a malicious cellular tower, you're not going to know the difference. And what ends up happening specifically is, if the malicious cellular tower asks you for information, your phone just gives it up. Same thing with like the physical port on your phone. Your charging port typically also is a trusted port. So anything that gets plugged into it is automatically trusted by the mobile device. Now, this is definitely being worked on so that this is not the case. So hopefully relatively soon that won't be the case, but for now, sadly, it is. Also, the operating system asks for specific permissions from the user before allowing certain apps. There have been certain safety features and controls put into place to kind of help prevent this from happening. Like, if you have an app that wants to access GPS or the microphone or the camera, it specifically has to have explicit permission from the user before doing so. And oftentimes, even if you don't realize it, users often just say yes, allow, and ignore it because there's a pop-up that just says, can I access this? So again, that user training comes into play. Again, users simply grant permissions to the apps without really looking at what's required. Why is that being required? Users just don't want to be inconvenienced. So what do you need? Sure, allow everything. That is why user training is a portion of the control for mobile devices. We haven't really figured out how our mobile devices are actually using all of our personal information. So that's the privacy in there is what's stepping up and becoming concerns. Oftentimes we forget that developers who harvest our user data typically do so behind our back, and sometimes they even just, not even behind our back, they just straight tell us, yeah, we're doing this. Temu is a perfect example. And we know that through external testing that when we install apps from that organization, they access and transmit all our mobile device data back to their parent company. So apps were straight actively spying and stealing data. And even then, users were like, oh, I don't really care. So major app stores will counter this threat by checking for specific features, code verification, and verification of terms and services. And if they do encounter them, they get pulled from the app stores. The omnibus for security and privacy does remain with the end user. It's up to the end user to stay diligent enough to make sure that they are protected. While there are some pluses, because mobile devices do allow us to stay connected. They're always on, they're always there. And again, this is both a pro and a con. Smartphones do have specific messaging. iPhones use iMessage. Android or Google use their variation. They allow for email messages, phone calls. A lot of the older issues with legacy communication, the time component, have been removed. So we also have things like voice over IP, opens up way new channels for wireless communication, such as online chat, presence detection, mobile handoffs, a little easier to Wi-Fi. All of that allows us because of our wireless technology. And when I say wireless, it's not just wireless like home data 802.11. It could be Bluetooth, it could be Zigbee, it could be WiMAX, it could be satellite, it could be other radio frequency wireless technologies. Cellular is a growing area within wireless high-speed data. 5G is a huge portion of that. Now, while not all the entire country has 5G, 5G is located in most of the major areas, and that has increased the ability to do cellular data. This then allows us to start introducing additional online-only based resources, i.e. cloud. This allows for multi-channel communications anywhere, anytime, on any connected devices, as long as you actually have that data connection. This concept is more of a unified communication, and this is brought through the connectivity that is already there. And that connectivity allows the connection to the masses, but sadly, there is a price. At the price of security, we give up protection for more convenience. There are some positives with this, though. We have the rise of the mobile worker. So, as things have occurred, our wireless technology has allowed us to do more remote-based work. For the consumer, the smartphone, again, is all about convenience. But in the business realm, it's the convenience, but it opens up extra layers for the business to actually operate. The employees can be mobile. They're no longer specifically tied to an office. We have that remote capability. The mobile revolution basically heralded in the era of securing the remote computing devices. A good example was 2020. COVID hit, and we had to transition to, in the workplace, to a fully remote workforce, unless you were mission critical. And a lot of people didn't think they could do their work remotely. Turns out a lot of them really could. Then after a few years, it was the, let's get back to normal. You shouldn't be working remote. Let's get back to the office. And even then, people were going, well, why? I can work remote. So all of that is truly because our wireless functionality. The fact that we can be anywhere at any time, connected to any devices, and still be able to do our job is the big thing. That grants us the freedom of accessing the resources that we need when done appropriately, securely. These resources fuel the development and the innovation to tear down that traditional network concept, the border network, the edge network. Now we have a borderless network, meaning that we're not tied to the traditional controls that used to be there. There isn't an edge that we put a firewall that protects everything, because our devices can not just go through our edge. They could go through mobile devices. They can go through cloud devices. They can go other routes. Thus, securing just one edge doesn't make sense anymore. What gets interesting is the networks are designed with more traditional layers of protection, fortification. And that meant with the rise of the working force, we've had to readjust how we think about security. Access anytime from anywhere for any made geographical centralization of a computer asset behind any type of barrier. We didn't think about that. So this common theme of these traditional applications, they're no longer suitable for the common user. By 2010, businesses started to see the benefit of cloud computing. Fast forward almost 15 years, cloud computing is in full swing, and now there is a conversation of the value. I can do things like software as a service, but is it a better value than being able to purchase the software just outright? While it may be cheaper in terms of monthly cost, it may not be cheaper in long-term cost. So there's things here. So there is a hybrid style of mobile applications appeared that will inherit both native with local interface, but utilize application programming or some type of back-end cloud. Again, some of it could be something stored on your local device, where the bulk of it is going to be stored on a website, web server, cloud-based application, and you can interact back and forth. Music apps are a great example of that. When I travel, I can make sure that my music app has downloaded all of the components it needs to my local device so that I can listen to music while on the airplane. While I get off the airplane, it normally deletes my local copy and then reconnects back to the cloud service to sync over all of that information. All of this allows us to have that mobile workforce. So with the integration of cloud technologies, mobile apps became fast because the developers could now use this MASH setup in minutes instead of months, being able to streamline the application development. The early cloud did have some weird things going on, but between cloud and mobile integration via the mashup application, this did result in unsecured data communication where we had privacy and integrity concerns. Though oftentimes applications have had to address that specifically because of state or federal regulations, this is still an area that is still of concern. The mass proliferation of cloud-based applications, including processing, storage, and transmission, including the infrastructure, the end of perimeter fortification, is one of those concepts that we have to look at. Is the data really secure? How can we audit? How can we verify? So this concept of a centralized fortification or castle type protection mode has to be rethought. Part of that allows us to move from the castle and moat mentality to a zero trust mentality. So basically, with rapid change of IT and the landscape of how we do our security and our protection, we've had to figure out a new approach to IT security. That's the zero trust model. Traditional fortress mentality technologies kind of are out of date. Relying on a single firewall or VPN isn't really there anymore. It is replaced by a more flexible and granular, more policy or profile-driven system for identification, for validation, verification, our AAA functionality. This allows us to have finer control and fine-tune our permission-based actions based off of our authentication and authorization commands. The focus on security moved from the user and device to the overall network itself. The network should be self-defending at a certain point. At the network level, the security model will determine that there is no difference between an inside and outside because all the devices are, or should be, considered untrustworthy. Because a user bringing a laptop in could be the same as a workstation on the network. Are they trusted? Should they be trusted? How should the network handle that? And oftentimes that is the point of zero trust, is everything is deemed untrustworthy until a certain profile or configuration is actually set forth to protect and trust those base devices. So instead of employing the castle and moat model used by VPNs built upon clear distinctions of inside and outside, the network has the assumption of trust. The network can figure out what it trusts, what it doesn't trust. The zero trust model was published in mid-2016 by Google, and it was quickly adopted as it kind of filled in that SaaS model or software as a service model. The advantage is outsourcing erroneous tasks to a single sign-on or firewall, IAM, to cloud providers was relatively easy at that point. Only within a few years, business networks changed drastically enough from being centralized data centers built on that castle moat mentality, single protection area, to being more cloud focused, utilizing that zero trust model. Now, I'm not saying all companies do, I'm not saying that most companies do. I'm just saying that there are companies out there that are making that transition, and so the organizations have to figure out how to keep pace with it. So that transitions us into the more mobile cloud. Cloud computing, again, has been a major disruptor in enterprise security architecture and design, as well as how workers do their job. Businesses, regardless of size, have had to shift to operate away from the traditional data center centralized mode to more of a cloud. Now, granted, not all businesses, but more businesses are moving more towards the flexibility and controls of that cloud, whether it's a private cloud or public cloud or things of that nature. Not saying that one is better than the other. They're different, and so you need to understand that companies, at least some, have moved towards the cloud because they found that that was their best way to manage their network. Cloud architecture does provide a more convenient, efficient, sometimes cost-effective, not always, but you need to verify, way of hosting applications. Again, being able to host an application and sell it could be a form of software as a service, but the big thing is you need to verify that it is cost effective. Sometimes the cloud is not cheaper. All of that allows for us to do things such as bringing the on-demand as well as self-service from the physical realm to virtual, and allows us to move to computing resources via the internet. If you need a VM spun up, if you need X services spun up, you can now do that, whether it's a virtual machine or physical machine that is allocated on the cloud, and this works. Amazon AWS, Microsoft Azure are two of the big ones where literally I need a VM. Within seconds you can spin up fully functional VMs that are hosted in the cloud and not on your equipment. This all deals with the ease of access and the confidential information controls that should be there to protect that data. Again, the biggest concern is security and privacy of that data, but when done correctly, you should be okay. So that moves us into the concept of this MCC, mobile cloud computing. This will focus on the distinct combination of mobile and cloud and wireless communication. These together bring cloud-based computational storage resources to the mobile user. You want a virtual machine you can run on your phone? Sure, you can do that. You want high-speed bandwidth because you have cellular data that's attached to that VM? Sure, why not? This makes it possible for cloud-based mobile applications to execute on pretty much anything. Again, that's because the actual processing and resources aren't really on your mobile device. Your mobile device is just connecting to a remote resource. So how does that differ from other things? How does that differ from cloud apps versus mobile apps? Again, the native mobile app is more OS specific. It's typically downloaded from the App Store. It's stored on your local device. It's processed on your local device. Mobile apps run externally, not on the device itself. The device itself may just have a small applet that actually allows you to interface with the remote app, but it's not normally on your machine or on your handheld device. Deploying wireless, again, different things, different areas. We've had wireless for 20 plus years. Wi-Fi was on its way to surpass physical cabling in 2005. It's come a long way. The spike of IoT and consumer, industrial, and all the other major areas for IoT has only drastically increased the need for wireless technologies. These new techs basically allow us to work in resource-constrained areas. Again, your IoT device may not have the computational power to do many things. It may just allow for basic wireless connectivity and an on-off option. That's it. So we also needed to work with low power, shorter range or even longer range depending on the requirements, and you may not have appropriate data throughput. If you have too many devices that are sending wireless signals, you also might have to deal with additional noise. It really just depends on the circumstances. We had to cater to a vast array of technologies, vendors, sectors, and so much more. What's interesting is we normally talk about IoT, but we just kind of ignore the industrial portion of IoT. So there's a lot of areas for IoT. Industrial IoT is one of the big ones. Machine to machine. That's been a huge area. M to M. Global communication. I work with several organizations where they'll have their industrial people back east, and they're remotely monitoring all of the equipment back west. And again, this allows them to be able to manage more equipment with less specialized individuals. It allows us to do the ultra distance communication. There are challenges, especially when we're looking at wireless technology. Again, cost, efficiency, range, longevity, pace of technology. All of those things really play a factor into it. We also have other IoT, not industrial, but just general IoT concerns. Power technologies, whether it's low power, high power, single chip, low power chip. So those are areas that have to be examined. Oftentimes, we do have ultra low power technologies designed to use low or really efficient power utilization for communication. We do have a wireless technology for that. That's 802.15.4. And so 802.15 is Bluetooth, but .4 is a different substandard. And again, there's tons of wireless communications out there. So Bluetooth, Bluetooth Low Energy, Bluetooth 4, Bluetooth Smart, Zigbee, Z-Wave, radio frequency, NFC, Thread. Thread's actually one of the more common ones. 6 low wireless personal area networks. That one's always a mouthful. These are all growing technologies. Thread is one of the big ones. That is one of the up-and-coming technologies. We also have other types of interconnects. Again, free space optical, WiMAX, which is our old analog TV, frequencies that have been released and then repurchased, and then using that current infrastructure. We have our very small aperture terminals, our VSATs. We have our software-defined WANs. So these are all areas for wireless interconnections. This is not a complete list either. Like, this is a very small list. But then there is a whole plethora of just WAN technologies. We have things like Sigfox. We have long-range WANs. We have low-power WiMAX or low-power Wi-Fi. We have millimeter radios. So there's a lot of long-range outside normal network technologies that can still be deployed. We also have cellular. We aren't reliant on just 4G and 5G or LTE. We actually do have several agencies that do private LTE-based networks. This is a current issue that traditional Wi-Fi fails to meet because of the large-scale wireless LANs that are out there. But this is one thing that LTE does actually allow us to interact with. It has emerged as a solution to fill the gap between the private wireless networks and the public cellular carriers. The private LTE does deliver a dedicated, normally fixed cost, better connectivity, and better security wireless system long range. That's the key there, is the range. While there are licenses, there is some shared and unshared. There is some unlicensed spectrum for radio frequencies. So there are some things to consider with our private LTE. There are ways to reduce the cost and the congestion. This will work over different frequency bands, so you're not just tied to 802.11. It can handle a vast amount of locally attached devices and their traffic without having to go to an expensive pay per bit or pay per megabit or megabyte carrier or a public LTE provider. The ideal stepping stone to moving into that 5G space. Again, privacy and security are the two major concerns. Security concerns aren't going away. So, wireless placement is a huge thing. While wireless LANs are convenient and, again, typically very insecure. So you need to look at the wireless protection that are there. Things like WEP and WPA and WPA2 are all old and dated. WPA3 is the current wireless protection standard, and that's the goal, is to get everything to a current wireless secure standard. You also have to look at physical components of wireless, such as coverage, antenna area. Here in this photo, we have a centralized omnidirectional antenna, and it's going to go around the office and through the office walls. It doesn't just stop. So there are ways to curve this wireless so it may not leave the office. Now, it does require some more planning, but there are ways to secure the radio frequencies to minimize the exposure outside the office. Even within mobile IP, there is still a security concern. The phones are no longer being shipped with Bluetooth enabled in discovery mode. That way, there is at least some protection. Security has been hardened because there's been enough public outcry so that the average user at least has some basic protections. Smartphones are now trusted for using e-banks, e-commerce, and emails. So, again, a certain level of trust has to be there. This does mean cyber criminals have become adept to intercepting cellular signals and being able to work with them. So again, users need to be mindful of the technologies and be better trained. Alright, that is the end of this module. We talked about application and security controls, zero trust, mobile cloud computing, wireless tech, and then we wrapped up with Internet of Things, connectivities, and network. Thank you. Alright, that concludes this lecture review. Again, all of this material is copyrighted by JB Learning. I was just providing video lecture on their official PowerPoints. Questions or concerns, definitely feel free to reach out to me. I'll answer them the best that I can. Thank you for listening to this lecture review.